We're going to move to graphing linear equations using slope and a point. Last time, we used slope and a y-intercept. Now, we replace it with a point. Okay? Okay. Let's have example. Graph negative 8x plus 6y equals negative 12. So again, this equation is in the standard form. So we need to express this into slope-intercept form so that we could easily identify the slope. Okay, let's do that. So you have the negative 8x plus 6y equals negative 12. So remain 6y in the left side. And then we need to transpose negative 8x. So that becomes 8x minus 12. And then you divide each term by 6 to get y. Divide 6x minus 12 over 6. So 6y divided by 6 is y. 8 over 6, that can be simplified. Their common is 2. 8 divided 2, that's 4. And 6 divided 2, that's 3x. And then minus 12 divided 6, that is 2. So you have here, so meaning your slope is 4/3. But we need to find another point. So okay, let's just since we have here equations is expressed into y in terms of x, so we just get x. So sample, if we have x is 3. Okay, let's do that. So y equals 4/3 x minus 2. Okay, substitute 4/3 times 3 minus 2. So you can cancel that out, meaning 4 minus 2. So that becomes, meaning y is 2. So you have a ordered pair 3, 2. Okay, let's start at 3, 2. So 3, 2, that is in the first quadrant. And then from your point, you execute your slope 4/3. Okay, since if we're going to execute 4 is positive, so upwards. So this is 1, 2, 3, 4. So this we have as you can see, we have small space. So why we use downward? Yeah, you can do that. So the slope is negative 4/3. You can also have m as negative 4 over negative 3. So since negative 4 over negative 3, when you simplify that, that's still 4/3. Okay? So negative 4 is downwards. 4 units. So 1, 2, 3, 4. Stop. The negative 3, that means to say to the left. 3 units. So 1, 2, 3. So we stop there. And that is 0, negative 2. So, and then connect the points. So there are really circumstances like this, guys, when you have smaller spaces, so you can use negative. Okay, just remember that you still could get the correct slope. Okay, let's have example number 2. You will graph x minus 3y equals 15 using slope and a point. So the same thing, you need to express this into y in slope-intercept form. So you have there negative 3y, and then you transpose x, that becomes negative x plus 15. And then So to get y, we need to divide each term by negative 3. There's no 1. So x equals negative 3 plus 15 over negative 3. So you have your y equals, so you have your negative x divided negative 3, that becomes positive. And we all know that the numerical coefficient of x is negative 1, or so since there's no negative already, so that becomes 1/3 x. 15 divided by negative 3 is negative 5. So the slope is 1/3. And then you get another point. So if x is, how about 3? So y equals 1/3 x minus 5. Class, why I choose 3? Because here, class, look at this. Silly, you can cancel that. It's very easy. So that becomes 1 minus 5, meaning y is negative 4. So you have an ordered pair 0, negative 4. So let's start at 0, negative 4. And then you execute the slope, which is 1/3. Okay, so meaning 1 unit to the upward, and then 3 the run, meaning to say 3 units to the right. So 1, 2, 3. So meaning that this point is 3, negative 3. And then you connect the points. Okay, so this is the graph of the equation x minus 3y equals 15. Example, we need to graph 2x minus 3y equals 6 using slope and a point. So the same thing, we need to express this into slope-intercept form. So negative 3y, and then transpose 2x, it becomes negative 2x plus 6. And then to get y, we need to divide each term by negative 3. So you have negative 3y divided by negative 3, that's y. Negative 2x divided by negative 3, simplified, it becomes 2/3 x. Okay, 6 divided by negative 3, that is negative 2. Meaning, our slope is 2/3. And then, let's find another point. Okay, to find another point, so we'll let x still 3. Okay. Class, it's not always 3. It's just that the denominator is 3. Okay. It's like this. Oh, you can directly cancel that out. So that means to say, okay. For you to have another understanding, let's erase. Let's try another number. How about 6? So that you have other options. So 2 times 6, that is 12, divided by 3, that is 4. Minus 2, that is 2. So meaning you have an ordered pair, 6, 2. Okay, let's graph. So let's graph first the first point, which is 6, 2. So here, 6, 2. And then you execute the slope. So run 2, mean to say 2 units upward. 1, 2. And then 3 run, that means to say 3 units to the right. 1, 2, 3. So you stop. So this is 9, 4. And then you connect. Okay. So this is the graph of 2x minus 3y equals 6. Okay, to sum up, class, when you graph using slope and a point, so first you see to it that the linear equation given is expressed in slope-intercept form so that you could get your slope. And then from your slope-intercept form, you could use that equation, and then you could you find any values of x so that you could get a value for y. And then that time you have a point, and then you plot the point, and then you execute the slope, and then you get another point, and then you connect the points, and then you have a line already. Okay, that's it. Thank you for watching, and God bless.